We are often asked at the Rome-Floyd Visitor Center exactly how did the equipment that's out here on our lawn work? Well, we have an expert in the field today with us that's going to talk to us about the Noble Machine Shop Lathe. And not only is he going to talk about it, but he actually was the last person to operate this lathe. And of course, this lathe is very important to the history of Rome, and it was brought here in 1847 on a steamboat all the way from Pennsylvania to the Noble Foundry, which of course, as you well know, was the foundry that created the Noble cannon. And it created other things too, but there's a long history of this lathe that actually sits on the campus of the Rome-Floyd Visitor Center. With me today is my guest. Many of you know him as Guy Mathis. A lot of you know him as Flue. And Flue actually has a great history, knows a lot about this lathe. Of course, was not around, by the way, in the days of the Corliss steam engine, but also understands because of his long background of how that particular piece of equipment worked.
I was the last person to operate this piece of machinery. In fact, I used to sit on a little metal stool up here and operate this. I'd sit up on the carrier and operate the feeder, which here you have a what we call a faceplate.
Which you said was 6 feet?
Yeah, it's
across.
probably a 6 foot in diameter, and you bolted your material of what you're machining. You bolted it to the faceplate, and it would swing up. You could later on, and I don't know if Nobles did it or the Davis, but they'd cut out a gap here with a torch, took a section out of this carrier track where they could swing a 10-foot piece of material.
My gracious.
So they could machine up, this machine could machine up to 10 foot in diameter. And so I'd sit up there, and you operate this machinery. You can switch from two different cutting tools, and which you operate it with this type wheel here. This here operated your carrier. Go up and
this
down.
this is the carrier here, this flat piece.
And you could just bring your cutting tools up into it. If you had a larger piece, you know, you'll be sitting out here somewhere.
Okay. And what was that portion?
That's what they call the tail stop.
Okay.
If you had a big shaft that you was cutting, then you would come here and you'd have a. If it was, you'd drill out, or either it was a open shaft anyway, this point here would steady that piece of shaft.
Okay.
And then you'd have to take these bolts, loosen this, and this traveled up, and this right here fed that end stock right there.
So you would actually physically turn it.
Yes, and you just wheel it in till you get up against and steady the in center of the piece of stock, the shaft or whatever you're machining, and then when to dismount this, you just move your tail stock back, and then.
And you're moving this by hand?
Yes. Well.
Or even this part by hand?
Yeah. Now, you remember this thing wasn't as rusty
Yeah.
then as it is now, but. You had now this type thing here. I'm sure they loosen these plates, these bolts here. Loosen the tension off of here, and this being greased and all, they probably had a come along or chain fall type thing to get this in position.
Okay.
Once you had a piece of material in it, then you didn't move this until you finish machining. You have a wheel here that's steps down in different sizes, and which that controls the speed of your machinery.
Okay.
So you got larger, then you go down to smaller, and whatever speed you want to
actually
turn, you have, and you got to have the matching belt that goes up there to keep it in operation, and that controls the speed on this machine.
And was there also a belt that was driving this mechanism as well, which would, I guess, move? What did this actually do?
Yes.
That moved the carrier?
Yeah, you see, you could feed off here to operate your carrier. And but mostly it was done up here
Right.
with by hand to shift it up and down the carrier here.
Now, I know that you, using this, actually used electricity.
Yeah.
Tell us a little bit about, just because of your mechanical engineering background and understanding this equipment, how in relationship in the 1860s did this work with a Corliss steam engine like the one that's here on the campus?
To produce steam, you got to have fuel, air, and water.
Okay. So
But anyway-
that's your belt driver,
Right.
like large.
Right. So ever what your source is on steam will operate the shaft on your belt, flat belt. And back then it was this type engine, and you have a long shaft in the ceiling of the building that you're operating out of. And this shaft has different size belts for different machineries. That's the purpose of it, and this is going to be your main drive going to your shaft in the sea.
I tell you, this is really a wonderful piece of history, and we truly appreciate you explaining it. Like I said, we've been asked, and none of us are industrial engineers to understand exactly how it works. But you know, it's just so hard to sometimes fathom that something like this is still around since from the 1847 was when it was built, and the amount of history that has happened with it. So thank you for sharing your story with us and helping us to understand better how this piece of equipment actually works.
It just brought a lot of memories back, and some things, you know, things just pass in life and people forget about, and where there's history behind it.
Absolutely, and now we've captured that history today for you. So now you know the lathe from the Noble Foundry, which of course manufactured Civil War cannons here. And of course, my guest today has been Guy Flue Mathis, who was the last person to actually operate this lathe at Alto Industries. Thank you, and I hope you've enjoyed this moment in history.